So one of the speakers, and you guys can guess which is which. One is a budding underwater photographer, and the other is a dedicated DIYer, a reluctant hobbyist athlete, and a clumsy aspiring musician. Please welcome Selen and Evgeny.
Will, we actually, unbeknownst to either party, we also worked hard on trying to put our arms around some hefty federal documents through this project. So we're going to give you the story of that right now. Thank you again for inviting us for the third time to this conference to share our exciting projects using R with this dynamic audience. I attended the past two conferences with my colleague, Danielle Larice, who's actually attending this year virtually. I'm joined today by my other colleague, Evgeny Kiselev, who's another member of our new data science team at our new office at the FDA called the Office of Science and Laboratory Advancement. So we have, as you can see, we have continued the tradition of giving quirky names to our talks. This is about the only conference where we can have fun with our titles and still present under our government affiliation. So we're going to continue to take advantage of that. So as you can guess from our title today, we will describe to you, and I do have to stick to my notes here because otherwise my 8 minutes is going to fly by. So we will describe to you a project which used natural language processing to perform a verification for a very administrative and a highly bureaucratic project. Namely, due to a large structuring at our agency, previous offices were sunset, people were reshuffled into new organizations, and each new organization was asked to produce its new concept of operations document, making sure all previously performed functions were captured and accounted for in the new document. So according to NIST Information Technology Library, a concept of operations is a description of how human and technical resources within a system are to organize and interact to result in an enterprise capability outcome. So the brute force way of doing this would be to have summer interns pore over legacy documents, make lists of functions and processes and key stakeholders, and then examine the new documents to make sure everything on their list was included in the new scope. So sure, it would create an easily doable, albeit boring project for some summer interns, but would it be an inspiring and welcome assignment? So especially since we can use automation to do this kind of verification in this day and age, which would give us much more flexibility since the tool wouldn't care how many documents you fed into it. So let's rescue our summer interns from being bogged down with this kind of assignment and free them to take part in projects that really do give them a valuable experience to make informed career decisions on. So let's delve into how we can use NLP for this project. And a quick disclaimer, this presentation reflects the views and opinions of the speakers and should not be construed to represent FDA's formal policies or views. So let's talk about So what we're trying to do is to automate the process by which we verify that the scope of the newly developed ConOps document captures all activities, functions, and processes that were dispersed across numerous legacy organizational documents. The tool to use for this is NLP, and R has a lot of NLP packages, so that's what we turned to for this project. But we didn't actually use a shiny app. We sort of tried to do a bunch of things on our own. So it was really actually nice to see Will's presentation. So this is how we approach this. We basically extracted content from a bunch of input documents and tried to prioritize the concepts found in the extracted content. So for instance, via word frequency or other means. So although we have to be careful because word frequency alone does have some pitfalls when it comes to discerning differences between documents dealing with different content. So we then made sure the high priority concepts are all captured in the newly generated ConOps document. So we don't have any gaps in the functions the new organization is supposed to carry out. And to achieve all this, we used NLP tools such as word frequency, principal component analysis, and a parameter called term frequency inverse document frequency, which was featured in Will's presentation as well, It's a function that's maximized for unique and most frequent words in a document. And we actually found this function to be the most useful in terms of discerning different types of content. So the schematic on the left here illustrates the complex structure of the organization the newly generated ConOps is trying to describe. So as any other government agency, we have a hierarchical organization that has components performing different functions, all the way from laboratory testing to quality management to training to stakeholder engagement. And the legacy documents in our library depicted on the right there are all different types of documents that were generated over many years through the evolution of the organizational functions. And they each bear an important nugget of the organizational landscape that we need to capture in the new ConOps documents. So one challenge we immediately braced for when delving into the legacy documents as our input files was the presence of many different text fields. So we saw everything from title boxes to ribbons, banners, tables, repetitive disclaimers, flowcharts, graphs, images, headers, footers, and etc. So we had to figure out how to deal with these fields. We opted to eliminate them for the most part, assuming that any info in these fields would have been discussed in the general text of the document and therefore represented redundant information. But a next iteration of the project should probably look at how to extract the info contained in these non-traditional fields. So again, this slide illustrates what we're trying to do. The goal is to find out if there are any sets of recurring words covered in reference documents, not covered in the new ConOps document. It's a very sensitive computer here. These would potentially represent gaps not included in the envisioning of the new organizational state. Similarly, we also wanted to find out if there are recurring words in the new concept document not captured in the reference library of documents. So these could potentially represent new areas of focus or scope or challenge regarding the new state, and we need to be prepared for these. So of course, we want the intersection to be as maximized as possible. And this slide shows our process map that we coded into R. First, we read the documents using either a PDF reader or an optical character reader, which better deals with the graphics and images. Then we removed non-value content such as headers and footers and document version history. Then we tokenized our unique, tokenized or counted the unique words, and we put them in a matrix. And we defined one token to be one word. It can alternatively be defined as a sentence or two words. So selection of the token roughly correlates with the resolution you want to study the document at. Then we removed the alphanumeric tokens and those with special characters. And we applied token length and frequency filters to get rid of words such as of, as, for, is, are, which would always win the word frequency contest, of course. They don't add any value. Then we arranged our output by the term frequency inverse document frequency function. Again, which basically gave us a matrix of most frequent unique words in each document. And this was actually pretty successful at allowing us to guess at the content of each document at a glance. And we compared the output to the newly generated ConOps document for overlap and gaps. And we used various visualizations to do that. And then we defined next steps to resolve any gaps. And now I'll turn over to my colleague Evgeny, who's going to give a more technical overview of our processes.
Hello. So I will start with illustrating some of the things that Selen just mentioned. And the first, we take out the headers. Here you have an example of the header that's going to appear on every single page of a document. So if you look at this header, you will see words like revised or science or regulatory. It's going to be overcounted drastically over the length of this document, and it's just 24 pages. And those words that can be dealt with mathematically, possibly, just setting up appropriate filters. But there are also words like method development and validation, words that are essential to the function of the office, and we would like to treat them appropriately. So we opted out for setting up a flexible function when we can specify a pointer word, so to speak, that would take out the whole header for us from every single page. And this is the part of our PDF reading function where we specify those for header, footer, and any document revision and version history, because those are also containing a lot of redundant information that we don't really need to account for. Additionally, as I mentioned, quite a lot of graphic would contain text information, flowcharts. This is an example of very poor resolution flowchart that contains a lot of organizational details that we would like to extract systematically. So we added another function that performed optical character recognition from those extracted graphics and did exactly the same thing with those. So in some cases, we removed content. In other cases, we've had to add it back in. Then tokenized, unlike previous speaker, great tool. We've done everything pretty much in one script, trial and error approach on our end. We tokenized by words. We removed stop words, including custom stop words that we chose to add. Often those are organizational assumed by nature of activity words like acronyms, names of offices, names of redundant names of documents, etc. And we store them those as data frames. And upon tokenization, we counted words. So we approach it with the frequentist mind for the approach to analysis with this mindset. We removed alphanumeric, special characters, periods, emails, URLs, etc., and applied frequency and length filters. Again, we couldn't possibly account for all federal government acronyms that could be in those documents, but usually there are 3 to 4 letters. So we applied those because on our initial analysis, we saw 3-4 letter words that might have meaning already implied by the nature of activity of organization. We didn't really need them to extract those concepts. So text tokenized, we removed special characters, counted frequency. In addition to counting frequency, we performed TF-IDF analysis. And Will's already talked about it. This is function that maximizes uniqueness of a particular term. Hopefully you can still hear me. By including that log at the end. So the first part of the function, term frequency, is just basically how frequently word appears in a given document. The log is basically adjusts for how frequently the word occurs across your library. Again, we might have used one of the same packages that Will was just mentioning. And the output, in addition to document title, would contain 2 lists of words. One with just frequency, the most common words in a document. Second, it's the most unique or ranked unique document words to that particular document. And here you can, just by looking at these words, you can say that the document deals with program of laboratory testing of samples. And unique words imply that it has something to do with medical products, something to do with coordination of those activities, and logistic as indicated by word supplies and exploration. So this is in fact from training manual for program coordinator, the person who deals and sample flow, results flow to and from laboratories. So these words describe this document pretty well, in our opinion. Here are two examples, and we proposed our way of interpreting these results, and we suggested the following hierarchy. First, we looked at the most frequent words, the lowest priority. The most frequent words, the highlighted in blue, the words that appear often, but they are low in uniqueness to a given specific given document. That means they're spread out across the library. Those words are in fact so common, the experts that are tasked with drafting that new concept of operation document has probably already accounted for those words. So low priority. Second, words with high uniqueness, but fairly rare. And you see them pop up on top for some of the documents. We're giving them lower priority because concept of operation for this particular task, the concept of operation is fairly high level document, would not require a niche terms and niche concepts incorporated in it. We still wanted to extract them for subsequent document generation, for business plan generations, etc. So we wanted to find those words, find those technical areas, but not necessarily give them priority here. The highest priority is, of course, frequent words and very unique. So that means those words set a given document apart from the library and define the content of that document. And again, here you can see them in red. For two documents, I believe this one is for proficiency testing within laboratories, and the second one is for one of the assignments, analytical assignments for the laboratories. So we can repeat this process iteratively. We can identify concepts of high priority interest, pass it to drafting task force. They will draft, and we will incorporate a draft once again and filter out the words and generate a new list. We opted out for generating a shorter list. Of course, we can extract it as long as the document itself with all the frequencies, but just for the human interpretability, we opted out for a shorter descriptive list for each document. Voila. Same principle. You see big words, you would like to take them out. Same as Will, we had our custom stop words. We also relied on TF-IDF to take out those common words. But this word cloud is basically the difference, just a visual representation of the difference of the extracted concepts versus those that already being incorporated. So these are the missing concepts that have not been put in yet in one of the iterations of the drafting of the document. And you can see some of them are fairly generic words. Some of them might be essential. Others words like monograph, sterile, radionuclides, so technical that they would not go into this document, but they are essential along with hierarchy, a word describing hierarchical structure of the organization. They might go into the other documents and worth paying attention to. So we're also curious about how we picked our library, whether it's representative, how can we describe the library of document that we set to work with. The library was expanding as the project was proceeding, but we wanted to see will those documents cluster? What sets one document apart from the cluster? Will some documents pull away from the cluster? Probably. And what defines documents separating from the cluster? Is it the document length, number of words, diversity of concepts included in the document, possibly? Here is an example. We have one main cluster. And just the final, the conclusion of this is the separation from the cluster is driven primarily by the size of the document. It should be taken with a grain of salt, though, because just probabilistically, the bigger the document, the more words you can squeeze into it. The more words you can squeeze into it, the more diverse document becomes from the standpoint of the computer. And because this is built on the scaled word frequencies, so you basically have the dimensionality of number of words in the entire library, documents that are lengthier, containing more words, would set aside from the cluster. And what we have, in fact, is the rock on the left. The comet-looking nucleus is the shorter documents, usually 10 to 15 pages, but no more than 20. And the documents separating twice or three times the size of that. And the new concept of operation stands out. It was a smaller document, but by the nature of it, we included as many concepts into it as possible. So it moved along with the other. So you could say it's the size that separates a particular document from the rest in this particular in this part of the graph, but the size drives the diversity as well. The document on the left is the control document. This comes from a relevant area, related area, but describing similar activities, but in different aspects. So if those are dealing with medical products, this is one is dealing with food. And you can see the terminology shifts dictating this document standing apart from the rest. And we included this document as a control. So as a conclusion, bad spot here. As a conclusion, these simple tools provided us with simple and easy ways to automate the concept extraction, describing the documents, and approaches such as frequentist approach or use of TF-IDF, which also relies on document frequency and characterization, helped SMEs quickly process the library and kept the number of hours to the minimum because they don't have to read it now. Also kept the task force to a minimum because they don't need all people working on it simultaneously. They can recruit additional experts as needed. Now we will bookmark the Text Explorer. I think is a great tool because we have other projects in the works that are highly relevant with semantic analysis and LDA. So very, very interested, but we would like to share with our colleagues our successes. Just a simple scripting, all easily accessible and available tools in R enable you to process the large library of the document. We added some caveats, as I said, removing headers and footers. Maybe you can get by without it. Maybe you don't have them. And large organization with a large collection of diverse documents can definitely benefit from these simple tools as hopefully we demonstrated and previous speaker as well. With that, thank you very much. That's it from us.